Section 20.1 Oxidation-Reduction Reactions. How do we determine whether a given chemical reaction is an oxidation-reduction reaction? We can do so by keeping track of the oxidation numbers of all the elements involved in the reaction. This procedure tells us which elements, if any, are changing oxidation state. For example, the reaction of equation 20.1 can be written: zinc solid, which has an oxidation number of 0, plus two protons, which each has an oxidation number of 1, yields a zinc ion, which has an oxidation number of 2, and hydrogen gas, which has an oxidation number of 0. By writing the oxidation number of each element under the equation, we can easily see that the oxidation number state changes that occur. The oxidation state of zinc changes from 0 to positive 2, and that of hydrogen changes from positive 1 to 0. In the reaction such as equation 20.2, a clear transfer of electrons occurs. Zinc loses electrons to zinc solid, is converted to zinc ion, and hydrogen gains electron as hydrogen ions are turned into hydrogen gas. In other reactions, the oxidation states change, but we can't say that any substantially literally gains or loses electrons. For example, consider the combustion of hydrogen gas. Hydrogen gas with an oxidation number of 0 plus oxygen gas with an oxidation number of 0 yields two hydrogen molecules, each with an oxidation number of positive 1, and an oxygen with an oxidation number of negative 2. Hydrogen has been oxidized from the 0 to the positive 1 oxidation state, and oxygen has been reduced from the 0 to the negative 2 oxidation state. Therefore, equation 20.3 is an oxidation reduction reaction. However, because water is not an ionic substance, there is not a complete transfer of electrons from hydrogen to oxygen as water is formed. It's important to remember that by using oxidation numbers is a convenient form of bookkeeping. In general, you should not equate the oxidation state of an atom with its actual change in a chemical compound. In any redox reaction, both oxidation and reaction must occur. In other words, if one substance is oxidized, then another must be reduced. The substance that makes it possible for another substance to be oxidized is called the oxidizing agent, or oxidant. The oxidizing agent removes electrons from another substance by acquiring them itself. Thus, the oxidizing reaction is itself reduced. Similarly, a reducing agent, or reductant, is a substance that gives up electrons, thereby causing another substance to be reduced. The reducing agent is oxidized in the process. In equation 20.2, hydrogen ions is the oxidizing agent, and zinc solid is the reducing agent.